Hello everyone. Today we are going to the first video of the data structures and algorithms. So let's welcome you guys, and I'm with me now there, and today I'll be representing on the topic of ListQueue and most important data structure concept under data structures and algorithm. So in this session I'll explain what is a queue is, the logic behind the ListQueue, how to implement step by step in Java, and finally we will look at its time complexity and some real world use cases. So by the end of this you will have a clear understanding of both the theory and the implementation of ListQueue. So let's start. So basically what is a queue? So let's start with what a queue actually is. So, an queue is a linear data structure that follows the FIFO principle, first in and first out. That means the element inserted first is the first one to be removed. Think of it like a queue in a bank or bus stop. The person who comes first gets served first. A queue supports two main operations. Those are NQ and DQ. NQ is to insert an element at the rear, or basically the end of the queue. So DQ is to remove an element from the front of the queue. And there are other helpful operations like peek and isEmpty. So let's talk about it later on. So queues are used in a variety of applications: CPU scheduling, print quizzes, handling customer requests, and more. So let's go to what is like queue implementations. So there are two common ways to implement a queue. Those are array implementation and the linked list implementation. So let's start with the array implementation. So here we use like a fixed size array. The problem with this method is that once the array is full, you can't add more elements. Even if you remove some from the front, unless you are implementing it in a circular queue. That is what we call as an array implementation. So let's talk about the linked list implementation. This is where like link implementation or the ListQueue. ListQueue comes in. So use the linked list, the queue a dynamic size, meaning it can grow or shrink is needed. There is no overflow unless your system memory runs out. So that's why implementing a queue, a linked list is preferred method in many real applications. So let's come to the main point, like what is a ListQueue? So a ListQueue is simply a queue that implemented using linked list. So each element in this queue is a node that contains of two parts. The main two parts is data and the next pointer. So data is where that stores the actual element value. And the next pointer, or the pointer we are talking about here, is what stores a reference to the next node in the list. The list uses two pointers, the front pointer and the rear pointer. The front pointer is the point to the first node, the one to be removed next. So the rear pointer is the points to the last node, the one most recently added. So when you NQ, you add a node to the rear. When you DQ, you remove a node from the front. This keeps the data flowing in the FIFO order. If you don't remember, the FIFO order is first in, first out. So let's go to how to visually imagine the structure of a ListQueue. So visually, you can imagine the queue as a series of linked nodes. The front points to the first node and rear points to the last. When you perform an NQ, the new node is linked at the end and the rear pointer moves to this next node. When you DQ, the node at the front is removed and the front pointer moves to the next node. If the queue becomes empty, both the front and the rear pointers are set to null actually. So as I said above, like we have talked about only two operations, that is NQ and DQ. So let's talk about the more other additional operations we can see in the ListQueue. These are the core operations that make ListQueue work. Those are NQ, DQ, peek, and is empty. So we have talked about what is NQ and DQ, but since for an we are going to memorize it again. So it's like NQ is inserts a new element at the rear, and DQ is removes the front element. And what is a peek? Like peek is where it shows the front element without removing it. And as for the is empty, what happens is that it checks whether the queue is empty. So let's go through the step-by-step implementations in Java. So let's first start with the node class. So the first step is to define the node class. Every node represents one element in our queue and it stores two pieces of information: the data is itself and the link to the next node. So I have given the code in here, so you can check the code while I am explaining. So after defining the class node, we can see there's an int data. In here, it is actually this variable stores the integer value we want in the queue. And from the next step, we can see there's a node next. This is a reference to the next node forming a chain actually. So in the constructor node, in the brackets we have shown the int data. In this constructor, we can say that we set the data and initialize next to the null because when a new code is created, it isn't connected yet. So this is the basic building block of our ListQueue. So next, let's create the ListQueue class to manage the nodes actually. So we have shown that we have defined a class called ListQueue. So in the second line, we have shown that node front, it's a comma and there's a rear. So in here, the front keeps track of the node that should be DQ'd next. Rear keeps track of the node where the next queue operation will insert. When we first create the queue, both pointers are null, meaning the queue is empty. So since we have done the basic part of this implementation, let's see how we add and remove data. So in here we have shown that an NQ operation. So let's go through this slowly. So here we have like node, new node equal new node. In the brackets we have shown that data. So we create a new code with the given data. For example, if data is 10, a new node containing 10 is created. And through the next part, we are checking if the queue is empty. If rear equals none, that means there are no elements in the queue. If both front and rear are set to this new node, this node is both the first and the last element. If not empty, if the queue already has elements, the next of this current real node is linked to the new node, effectively adding the new node at the end. Then the real pointer is moved to the point of the next node. So let's check the dequeue operation. I have shown in the code that from the first step we are going to check if the queue is empty. Therefore, if there are no elements to remove, we can print an error message and return -1. In the next part, we are showing that we take the value front.data and keep it in a variable called value. Then we are going to update front equal front.next, that part, effectively removing the first node and pointing front to the next one. So again, we are going to check after removing front becomes null. We also set like real equals to run, meaning the queue is completely empty now. So that finally we return the value that was removed. So next, let's talk about the peak and is empty part. So this peak shows the front element without removing it, while the is empty checks whether the queue has any nodes left. So let's go to for a demonstration. So now let's test everything in the main method. Through the given code, we can see that a new queue is created and we enqueue 10, 20, 30. The queue becomes 10 to 20, 20 to 30. We call dequeue, which removes 10, prints 10 dequeued. Then we have added the peak operation to show the display the current front element, which is 20. This confirms that our ListQueue works as expected. So as for in the beginning I have talked about time complexity. So all the major operations in the ListQueue in a constant time, which means it's a big O of one time. That means they execute in a constant time because we directly accessing or updating pointers. No loops or traverses are required. So as for the real life examples, we can review like print queues, CPU scheduling, customer service systems, and networking. Queues are everywhere, from hardware design to software applications. So to summarize the whole session, we have learned about what a queue is and how it works. We explored ListQueue, a linked list implementation of a queue. We looked at how to write and explain each operation in Java, and we have discussed its efficiency and real-life uses. ListQueues offer flexibility, dynamic sizing, and efficient operations, make it an essential concept for every programmer to understand. So, this is the main basic ideas and how now you have get a clear idea on what is a ListQueue is. So thank you for listening and I hope to meet you guys in the next video. Thank you.